Lab Guy here. This is the story of the $8 TV camera. I found this nifty video camera at the local surplus store on the 80% marked down rack. At that price, I couldn't pass it by. Of course, once I bought it, I now have to do something creative with it so that I didn't waste my money. This camera is a Sony DVC-2400 made in 1966. It operates on 12 volts DC and was used with a matching portable video tape recorder, the DV-2400. Separate horizontal and vertical sync pulses were provided by the VTR, as well as the DC power to run the camera circuits. Fortunately, I built a standalone television sync generator a few months ago, and it has been searching for a purpose. This is it. I have been using some clever jumper wires for my projects recently. These are tipped with female jacks that fit onto standard 0.1-inch spaced header pins as found on the edge of many computer motherboards, providing connections to the front panel buttons and lights, for instance. These are ideal for interconnecting many electronics projects. These jumper wires also fit on the pins of the camera connector quite conveniently. These particular jumpers are now abused, so I will reserve them for just this type of project again in the future. The other end of them are normal and still connect to the sync generator quite nicely. First, I hooked up two wires to pins 9 and 10 in the camera connector. Pin 9 is for the plus 12 volts and pin 10 is ground. Power will come from my big fat lead-acid battery. Next, I used 3 more jumper wires to connect the sync generator project to the camera connector. Pin 3 is vertical drive, pin 4 is ground, and pin 5 is horizontal drive. The sync generator is powered from my general purpose AC powered supply because it requires plus 5 volts and negative 12 volts to operate. Drive pulses are used in the camera to synchronize the scanning oscillators to a stable source. These pulses are also shaped and adjusted to eventually form the sync pulses in the video coming from the camera. Without drive, the output video has no sync pulses. Many people hook these cameras to a power supply and then declare the camera bad because it will not synchronize the TV monitor. Because the camera and viewfinder scan circuits use the same oscillators, the viewfinder is always in sync with the camera. This causes some confusion to the inexperienced experimenter the first time they encounter this type of camera. Finally, I made a coax jumper to hook my TV monitor to the video output of the camera. Video out is on pin 1 of the connector, and the video ground is on pin 2. With power applied, I discovered that I could see a picture on the TV monitor, but not on the internal viewfinder. I did not troubleshoot this problem yet. Someone before me had turned every pot in the camera, of course, so within a few minutes I was able to readjust the settings for the camera portion. We are now getting a picture from the $8 camera. That filled in a boring, rainy Saturday afternoon and was very fun. And it was also a good value.